This exam question comes from the 2023 Higher and Foundation Tier papers.
It's all about waves. It's all about the way that waves change speed, the way that waves travel. They refract because of that change in speed as they cross over a boundary. So here we've got a question all about a ripple tank, which is a way that we can demonstrate waves in the classroom. And we've got shallow water on one side of the diagram and we've got deeper water on the other. And then this thick dark line here represents what we call a boundary. These fainter grey lines here, they are showing what we call wave fronts. They represent the matching points on a wave. So the distance between each of these is called a wavelength, and that will be very important in the part B of this question. So it says, complete the diagram to show the wave fronts in the deeper water. So it wants us to finish off what's happening here as the waves travel across. So what we need to remember is a couple of things for this. One, that the deeper water will mean that the wavelength is longer in this deeper water, so we'll need to spread them apart a little bit more. We need to remember that this direction of the wave that we're being shown here with the arrows is at 90 degrees. Can you see here how it's 90 degrees? It's perpendicular to the wave fronts. So we're going to use that line there and this idea that they are wider apart to build our diagram, or the second half of our diagram. You're going to need a ruler for this. I'm going to be honest, if you haven't got a ruler going into your exams, you need to get yourself one. And I'm just going to tilt the paper to make it easier for me to draw. Move your exam paper around as you're doing it to give yourself the best chance. So let's use that 90 degrees. You don't have to use a protractor, but you can use, you see how the marks on my ruler are pretty clear where we've got like 90 and 100. I'm going to use those to represent 90 degrees because they're close enough. So I'm then going to join where the wave fronts down here meet this 90 degree criteria here. So I'm just going to put that on at 90 degrees, slide it around until I'm happy, pencil on and double check it because I only get really one chance at this, don't I? Okay, nice and faint first. There we go. So there's my first one. We'll do this one next. So again, put my ruler on at, let's use a nice light one at 90 there. Ruler on there, about 90 degrees. I'll let you in on a secret as well. Your exam marker is not going to get a protractor out and check their 90 degrees. They are going to look at it. And if it looks about right, they are going to give you the marks. So if we straighten the page up so you can see what's going on, these are my new wave fronts. Let's check what we were looking for in this question, that they are at 90 degrees here. I'm pretty happy with that. We need at least 3 of them because look, 1, 2, 3 have crossed. If you want, you can try, although this one's going to be tricky. I don't want to do it for the sake of spoiling my diagram necessarily, but you see how that one there is going to go there, isn't it, if you think about it? Okay, so we've now got 4 wave fronts. We're getting super exciting. And they are evenly spaced, and they are wider spaced than the originals, and they are at 90 degrees here. Now, this obviously is the full mark answer. However, you may have not joined them to these points here, but get them equally spaced and at 90 degrees. That's going to give you 2 marks. If you've just got 3 lines on here at 90 degrees, that's going to give you 1 of those 3 marks. So you'll get a combination of different marks there. If we take a look at part B now, just swap onto the second part of this question. So a different experiment, the wave fronts pass over the boundary as shown below. You notice this time that they're coming straight on. So these wave fronts, again, are hitting the boundary, but this time they're hitting the boundary at right angles, meaning there's been no change in direction. It's not like that previous diagram we had a moment ago. So here, Sam is talking about the fact that the waves, or he thinks that the waves have a greater speed in deeper water than in shallow water. So we can see the difference between these two sides, and he's saying that there's a difference. So the first thing I want you to do is notice that, can you see the wavelength here? So the distance between the wave fronts is greater. That's the first thing I want you to notice. So we're going to say greater, you can say larger if you like, distance between wave fronts. And just in case, I'm going to say in the deeper or the deep water, okay? So that's going to get you a mark there. Then I'm going to say because and this is an interesting thing you need to know, is that the frequency stays the same. So the frequency of a wave always stays the same. That's one of those things that doesn't change. Even as it changes from shallow to deep and the wavelength gets bigger or smaller, the frequency will always stay the same. Okay, that's a no. You have to know that, all right? There's no hiding in the question there. That's something that you need to remember. So the greater distance between the wavefronts in the deep water, because the frequency stays the same, and this is key for this question, we need an equation from page 2 in the data booklet, which is v, the speed of the wave, is equal to the frequency times the wavelength, and that's written on formula sheet, remember, as, what am I saying? As wavelength, that's that funny lambda symbol, as wavelength gets bigger, v must also get bigger. Now, if you ask me, yeah, there's some remembering in this, but actually that's a pretty nice way to finish off a foundation tier exam paper. 6 marks there, done nice and quick. Use your ruler, make sure you know the key information about the way waves behave, and they are easy marks at the end. A little bit of a treat there, hiding at the end of the paper. Thank you very much. Remember to check out some of the other videos. Remember to subscribe and all the usual sorts of things. You can, if you like, even give us a thumbs up for the video. Thank you very much. Bye now.